Hello, everyone. Good morning, good afternoon, good evening, depending on where you are. And welcome to this Ophir Photonics webinar. My name is Mark Seletsky, Product Manager for Power and Energy Measurement Solutions here at Ophir Photonics. And thanks for joining us today. The topic we're covering is maybe a little bit of a niche topic, but an important niche topic. And we're going to talk about virtual meters. Now, I'm assuming that those of you joining a webinar of this nature are at least somewhat familiar with Ophir's product line, sensors, meters, power measurement, energy measurement, that sort of thing to some degree or another. So we're not going to go, too down to the most basic level, but we'll discuss things hopefully that'll be relevant. I hope that I found the appropriate balance between breadth and depth. Um, the total time of our webinar, it'll be a relatively short one, something like 30 minutes, maybe 35 at the very most. Questions, comments are welcome using the text chat box on the right side of your screen. And I'll do my best to respond either in real time or at a suitable point in the flow of the information. I'll be leaving my contact information up on the final slide for a minute or so after we're done in case you want to take down my email address and contact me offline. You're more than welcome to do that as well. Okay, where is my forward button? Here we are. Okay, I assume you're somewhat familiar with Ophir. I'm not going to spend time on that slide. So basically, first, I just want to make sure we're all on the same page, speaking the same language, explain what it is that we're talking about, what I mean when I use the expression a virtual meter or meter at all for that matter. And then we'll get into the details, the different types of virtual meter solutions that are available, the basic differences between them, mainly the interface options, the main benefits that these sort of instruments bring you, what essentially they allow you to do. Now, as you can appreciate, I'm going to be focusing when it gets to actual examples of actual solutions, I'm going to be looking at Ophir instruments because those are the ones that I'm qualified to talk about. And then before we end, I just want to spend a minute or two focusing on the RS-232 um, based virtual meter that we came up with not that long ago, 2 years ago, maybe, I don't remember, because there's some interesting things about it. Okay, so let's begin with what I'm calling an overview. So as I said, just to get on the same page, make sure we all are, using the same terminology and meaning the same thing by that terminology. Um, a very generic measurement instrument, you've got the sensor, which I don't want to say measures because that kind of covers everything, but the sensor into which is input the parameter, the sensor that directly receives the parameter that we're trying to measure. There's some kind of a processing that we do to that, and then there's an output. So the input parameter, it might be weight, it might be speed, it might be laser beam power, gets converted by the sensor into a usable signal, a processable signal. Generally, we mean an electronic signal that gets processed and gets turned into an output. So in our case, we have the laser power sensor, for example, which receives the laser beam and generates an electrical signal that represents the parameter of that beam that we're trying to measure. Let's say, for example, the power in the beam. Um, the signal that comes out of the sensor is proportional to the power in that beam. Then we process it, we do all sorts of things, and eventually we're outputting a readout, such as a numeric displayed reading of the power in the beam in this example. So the sensor outputs a raw analog signal that's proportional to the power or the energy or whatever it is. In the case of Ophir sensors, that raw analog signal happens to be an electrical current, a very, very small electrical current, microamps per watt or something like that. The meter samples amplifies, processes, measures that signal. Now, so far, all we know is that signal is proportional to the power. The constant of proportion, which means how do we go from getting bigger, getting smaller to 3.7 milliwatts, that constant of proportion is what we measure when we calibrate that sensor. So we're measuring that analog signal coming out of the sensor. We're reading the calibration data that's stored in the sensor's memory. In the case of Ophir sensors, that memory is an EEPROM that's located in the connector at the end of the cable that comes out of the sensor. And then all sorts of processing and calculating and so on eventually gets turned into a display of some kind. Two main types of meter. We used to call the meter a display up until some years back, and then we decided that that doesn't really say what the thing does because it's much more than just a display. So there's a handheld meter where the meter basically does everything we just said, and it includes its own built-in display screen. So the output happens on that same instrument. And what we're going to be talking about today is virtual meters, where the meter, in this case, that slightly fat connector at the end of the cable, that's a meter. It does the same thing, sampling, processing, measuring, amplifying, calculating, etc., etc. The only thing that it doesn't do on board is the actual display. The display gets outsourced to software running on a PC or something like a PC. So virtual meter, we used to, in the old days at Ophir, we used to refer to these as PC interfaces, but too often we were asked, well, why do I need to buy your PC interface? Why can't I just use an off-the-shelf hub that I buy, in a store? And then we realized, okay, it's a misnomer. It's not a PC interface. It includes a PC interface capability, but it's a meter. The only thing that it doesn't do that a handheld meter does is the actual displaying. So in recent years, we've started calling these virtual meters. So Ophir virtual meters, they do everything that the handheld meters do, except for the displaying, which, as we said, gets outsourced to software running on the PC. The standard workhorse software for Ophir USB speaking devices, but not just USB. Let me rephrase that because that changed a couple of years ago. The standard workhorse PC software for Ophir instruments, we call it StarLab. Most, maybe all of you are probably familiar with it. So all of our virtual meters are supported by StarLab, including those virtual meters that are based on other interfaces, not just USB. That didn't used to be the case until a couple of years back, which is why, out of being too used to things, I started to talk about USB-based instruments. In addition to being able to work with the StarLab standard PC software application, they can also communicate with an external system. And we're going to just mention that briefly in a moment without getting too bogged down in the details. So let's look at the different options that are available, the different types and the different interfaces on which they're based. So we have virtual meters that speak USB, RS-232, Ethernet, and Bluetooth. So those are the interface options that we have on the table at the moment. So let's start with USB. We have a device we call the Juno. You don't really get much of a feel for its size. You know what? I think I have one right here. Hang on. Yes, this is a Juno. Okay, it looks like a slightly fat connector, essentially almost zero footprint. We have the Juno. On one side is the D15 connector to which we connect the sensor's cable, and the other side is a USB. it doesn't need a separate power supply. It's powered from the USB. There's the Juno and there's a Juno Plus. They look very different. The truth is they're pretty much exactly the same. The only difference is, other than the appearance, is that the Juno Plus also has an analog output. We'll explain what the analog output does if we need to in a couple of minutes. When measuring energy per pulse for a pulse beam with an energy sensor, a pyro sensor, it can capture and measure every pulse at up to 10 kilohertz, both of them. They support all Ophir sensor families except for one particular, except the Juno does not support we have a family of irradiance and dosage sensors. If you don't know what I'm talking about, it means you don't need them. But other than that, they support everything, and they support all the most advanced functions that we keep on developing as the years go by. Oh, here's the analog output. The WebEx tool that we're using, that we actually will be switching next month, but until now, and including now, we still use it. It doesn't support the animations in my PowerPoint file, so I had to kind of duplicate the slides. So, okay, so this is the analog output of the Juno Plus. Okay, another older generation USB-based virtual meter is something we call the Pulsar. Pulsar is actually a family of virtual meters. The reason there's a family is because there's three models: a 1-channel, a 2-channel, and a 4-channel Pulsar. The Pulsar actually can capture and measure every pulse at up to, when using an energy sensor that itself can measure every pulse at these rates, at up to 25 kilohertz per channel. It also has an external trigger, which can be used for detecting and logging missed pulses, or only paying attention to pulses within a certain time window and ignoring all others. It's a pretty neat tool. This is an older, sort of, not the oldest, but an older generation instrument. So there is some limitation in its support for certain of our newer sensor families. We're not going to get into the details of that. If that's a particular question we have on our website, I'll show you where in a moment. Compatibility table. The main advantages of the Pulsar, despite the fact that it's an older generation sensor and therefore older generation virtual meter, and therefore there are some limitations in what it can do. But its main features, its main unique features, are the external trigger, and also the fact that there are multi-channel versions of it and the very high speed at which it can capture every pulse. RS-232. This began only a couple of years ago as an OEM, as a customized solution that we developed for particular customer requests. We like doing that. Obviously, we'll do that only when it's justified. A square egg that's one-off, it won't make sense to get into a special development, but this case was different. And it turned out that this was a very eagerly sought after solution, and we developed a standard product out of it. So it looks like the Juno Plus. It's actually a little bit bigger. I don't have one here handy to show you, but this one is based on RS-232. So here you can see the D15 sensor connector, and here's an analog output like the Juno Plus has. On the other side, there's the connector for the RS-232. We're going to, as I said, spend a minute looking in a little bit of detail into the Juno RS for RS-232, just before we conclude. Ethernet. This also began as a special OEM, and we realized very quickly that, you know what, this is something that a lot of people are going to need, and it's actually now our second top-selling virtual meter. It does not support special sensors. We're not going to get into what those are, but it supports all the standard sensors, power and energy. I mentioned earlier that our virtual meters can be communicated with from an external system, not only from Ophir's StarLab software. Normally, communicating with our instruments from an external system from the user's own system is done via a COM object that comes embedded with that StarLab software. So even if you're not using StarLab because you're going to use your own software, the COM object is embedded in StarLab. The COM object is not compatible, or the EA1, the Ethernet virtual meter, does not work with a COM object. I found that out the hard way because a customer asked me a question about a year ago and I gave the wrong answer. And within a few minutes, it was brought to my attention that, oops, nope. But the reason that it doesn't work with a COM object is because the normal way of using an Ethernet-based device is from the user's own. It's just done differently. So the COM object wasn't quite needed when it comes to an Ethernet-based PC interface. Basically, what you can do with this is you connect your sensor to the virtual meter as you would with any other virtual meter. But that virtual meter, instead of plugging it into your PC, you connect it via standard RJ45 connector to the Ethernet network. For example, the internet, for example, and you might be located on the other side of the planet. You can connect to the Ethernet network. You had set it up when you installed it, IP address, all the things that you need to do to set it up, and then you can communicate with your ongoing experiment or whatever work you're doing over the Ethernet network. So there's essentially no distance limitation here. Bluetooth. There are some applications where any kind of a cable connection between the sensor and the software platform is just not an option. So we have wireless Bluetooth-based virtual meter. We call it the Quasar. You might notice that all of our instruments have an astronomical name of some kind. The distance, typically a couple of tens of meters, obviously depending on what's in between the Quasar and the PC that's waiting at the other end with a wireless communication between them. We also have an Android app that we call Star Viewer, so you can attend a meeting, and if it gets boring, you can check in on your experiment and change power scales or whatever it is. And that can be downloaded from our website or from the Google Play Store or whatever. You might notice on our website that there's an iOS version of that Star Viewer app, but that's not for this instrument. That's for another specific instrument called the Ariel. It's a high power, very small industrial power meter. It measures high power beams from a very short exposure. It's designed for situations like inside a additive manufacturing process chamber, something like that, where again you can't use a cable. But so the iOS is not meant for the Quasar. I'm just mentioning its existence because you might notice its existence anyway, and we don't want to cause confusion. Okay, so let's just talk about the main benefits that these type of instruments bring you, the things that they enable, that they allow you to do, and the ways in which they make your work and life a little bit easier. Small footprint, but they have very advanced capabilities because again, they're not just a connector. It's a full-blown power, energy, whatever meter, except for the displaying part. The Ophir meters, because the sensor's calibration and related data, meaning everything to do with the sensor's electronic identity, what kind of menu options the user will be prompted with, and so on. Everything to do with how you use this meter, all of that is data that's stored on the EEPROM in the connector at the end of the sensor's cable. The meter and the cable are fully interchangeable, hot swap in almost all cases. So you have one meter, it can work with a whole range of different sensor types, Ophir sensor types, obviously, that you might have and that you might use. So it's a free mix and match. And pretty much all of our virtual meters are fully compatible with pretty much all of our sensors. As I said, there are a few exceptions. I don't know if you're going to be able to read this, but there's no point trying to read it now. But if you look on our on our website, on the page of what we call the meter finder, there is a link to a compatibility table, which at a glance tells you those few exceptions, what's not compatible If it's not listed here, it's compatible. In general, when coming out with new technology and new advanced capabilities, maintaining backward compatibility with already existing older generation products is always a challenge. We usually manage to find solutions, but there are just limitations in how in how far you can manage to take backward compatibility. A huge benefit is the StarLab software itself. It's a very, very powerful software application, very intuitive and easy to use, and phenomenal capabilities. We have a whole video series about how to use the different features broken down into separate bytes so that you can go through this particular sections that are relevant to what you need to do. But I'm just mentioning that because I think that that's actually a very important thing. The user experience, that what your work will actually look like, is mainly a function of the StarLab software. So if that's of any interest, I warmly recommend that you just have a look at some bits and pieces of the video series that we have on the website about StarLab, just so you can get an idea of what this software is like and what it lets you do. Okay, just want to spend 2-3 minutes focusing on RS-232 because I think it's an interesting one, and it's not for nothing that this went so quickly from being a special custom solution to being a very, one of our more popular virtual meters. um, so basically, I mean, obviously, it lets you connect standard Ophir smart sensors to either the StarLab software application or to standard automation systems using RS-232. I will mention that there is some of you might notice that this has much more of the Newport look and feel than the typical Ophir look and feel. I assume you're all aware that Newport brand and Ophir brand are sister brands. We're the same company. So there is a Newport brand version of the Juno RS. One cannot mix and match one brand of sensor with the other brand of meter. That could either not work, or it could actually cause damage to the meter, but they do essentially the same thing. So if you're in a university and you're already using, let's say, Newport brand sensors, so you would use the Newport version of the Juno RS. It's called the 845 PE RS. Okay, it looks the same. It's almost the same. I'm just mentioning that because it kind of jumps out. Supports, as we said, in general, all standard power and energy meters and power and energy sensors, including we have a family of what we call beam track. It's a family of thermal power sensors that, in addition to measuring laser power, also measures the position of the beam centroid, and for some of the models, the size of the beam, all at the same time. Very, very cool product line. It also supports, we have a family of irradiance and dosage sensors. So if you're measuring, let's say, in UV LED applications, food sterilization, curing of adhesives or dental materials, whatever it is, and the parameter of interest is the irradiance in milliwatts per square centimeter, or the total deposited millijoules per square centimeter over the course of 10 seconds or whatever. So we have a family of sensors that measure that directly. We also have one sensor that measures using photometric parameters, where the human eye response is what's of interest. It measures illuminance and well, it measures illuminance, but it measures in SI units and in British units. So it can measure in lux or in foot candles. It does not support one specific special sensor. We call it the BC20. It's a sensor that measures the power in a rapidly scanned beam. So manufacturers of barcode readers would be interested in that sort of thing. So that's the one special sensor that's not supported by the Juno RS. It also does not support the old generation Ophir pyro energy sensors that we discontinued, I think, 11 years ago, but I doubt that that's going to be of any relevance to anybody now. Its outputs are obviously RS-232, and we mentioned the analog output. If you're measuring energy per pulse, it can measure every pulse at up to 500 hertz, nowhere near the 25 kilohertz of the pulsar, but okay. And it has support for all the advanced functions. In a moment, I'm going to just give a quick rundown of what those are. Analog output. So in addition to actually measuring digitally and getting the readout via your software or our software, there's also the analog output, and you can set it, the user can set it to either 1, 2, 5, or 10 volt full scale value. So if you're measuring power on a 1 watt scale, and you select a 1 volt full scale value of the analog output. So if right now the beam that you're measuring has a power of half a watt, so then the analog output will be half a volt. If you had set your full scale value of the analog output to 10 volts full scale, and you're on a 1 watt power scale on your sensor. So if you're right now measuring half a watt, the output will be half of 10 volts or 5 volts or whatever. So it can accommodate different control systems. It's a nice little bit of flexibility. A neat thing about it is it can work autonomously, meaning once you've set your full scale analog output value, it'll continue providing that correct analog output, even if you then are disconnected from the software. So even if you're no longer getting the digitally communicated readout, the analog output will continue. It'll remember what the full scale um, output voltage is supposed to be, so that it'll remain on what, let's say, the 10 volt scale. So if you're measuring half of your full scale power, you'll be outputting half of those 10 volts. So once set, the analog output remains autonomous, even if it's no longer in communication with the software, which is another neat bit of flexibility. Connectors are not industrial. Let's not get carried away, but they're semi-industrial. Which is, I think, pretty typical of the sort of situations in which an RS-232 based device is going to be used. I mentioned advanced functions, so just briefly a few examples. We have something called pulsed power, which enables thermal power sensors to measure high power from a very short exposure. Basically, it treats it as a single pulse, and it measures the single pulse energy, and you divide that, or the instrument will divide that by the known prompted input pulse, exposure time, exposure duration, and it gives the instantaneous power as a power readout, so that it enables you to use low power sensors to measure very high power beams, even if the sensor isn't designed to dissipate heat at the kind of rate it would need to, but the exposure is short, so that doesn't become an issue. Low frequency power, if you're using a photodiode based power sensor to measure pulsed beams, if the beam is pulsing at low repetition rates up to a few tens of hertz, there are some pretty challenging issues that can come up. Beat frequency between the pulse frequency and the sampling rate of the meter input. You have issues of momentary saturation. It gets complicated, so we have a special mode that we call low frequency power that takes care of those issues. That's a particularly important issue, for those working with VCSELs, which are typically pulsed at low pulse rates, short pulses, nanoseconds being pulsed at a few hertz, a few tens of hertz. Dosage, irradiance, a whole bunch of different advanced functions depending on the particular type of sensor that we're talking about and what it's used for. So these are just a few examples. So all of these are supported by the Juno RS and by those other virtual meters that I said support all our advanced functions. The older generation, like the Pulsar, has some limitations. Again, not going to get into all of them now. There's no point, but we have that compatibility table next to it. There's a another table that we call, what do we call it? Measuring modes available or something like that. All the information is there. We're as interested as you are in getting it right the first time, so you don't make any mistakes in your product selection. Target applications for the RS-232, any customer that uses lasers, basically. Industrial laser system integration. This is really like the natural place for an RS-232 based virtual meter to belong. Real-time monitoring via automation equipment, PLC, something like that, or performance verification during system integration when it's not already included in the system. Service tools, certainly. Basically, if you're working on what's going to possibly become an OEM application and you want to, run a sanity check on it, check that the concept actually works, and you don't want to start into a project yet, this could be a perfect solution because it enables you to use an RS-232 interface without starting to develop a whole system if you're not quite ready to give that the green light yet. So in summary, virtual meters are meters. They're not just interfaces. They're full-blown precision measurement instruments. They also have a recommended annual recalibration, just like the sensors do. They're excellent solutions in situations where all the work is done with the PC and you don't need a handheld meter with its own built-in display. We have virtual meters for a wide range of interface types. All of them can work with our standard StarLab software or with the user's own software. We call that an external system. For you, that would be your internal system. You get the idea. Okay, so that's what I wanted to get across. We're at 31 minutes, so I was pretty much I'm not usually very good with time, but I guess I got it right this time. All right, if you have any questions you want to ask online, in real time, you have a few more seconds in which to do that. Otherwise, you're more than welcome to contact me offline. I'm going to leave the slide up for another minute or two. My name again is Mark Slutsky, Product Manager for Power and Energy Measurement Solutions here at Ophir Photonics. This is my email address. You can also contact us through our website or through our partners in your various countries, whether it's an Ophir office or a representative. We want it to be as easy as possible for you to get a hold of us if there's any way at all in which we can help you and provide any kind of service. So I hope this was helpful. Thank you very much for being with us and have a great rest of the day.